Okay, this is another one of the questions that came up in Further Stats Chapter 1 that you wanted some help with. So let's have a go. Members of a group may enter a maximum of 5 photographs into a members only competition. Past experience shows that the number, so it's just the idea is this is why that's a 5. Okay, yeah, seems to be. We've got all sorts going on here. So let's just start writing down a few things. So first of all, we know that that's 0.25, isn't it? So we know that 0.5 plus A plus B plus C equals 1. So A plus B plus C equals 0.5. What else can we do while we're here? The expected values. So this statement here, so remember the idea is that 4 lots of the expected value of n plus 2 should be equal to 14.8. And we can take away 2 is 12.8. 12.8 divided by 4. So this tells me that the expected value of n should be equal to 3.2. So that's quite good to know. So we could write a statement with that now, couldn't we? So that's one of our equations. Another of our equations is going to be 0.2, 1 times 0.2, 0.2, plus 2 times 0.05, plus 3 times 0.25, plus 4b, plus 5c should be equal to 3.2. If we do a little bit of cleaning up, what's that? That's a 0.2, that's a 0.1, that's a 0.75. So let's just now call this 4b plus 5c equals, so what's that? 1.05. So 3.2 take away a 1.05. So that equals 2.15. So that's not bad. I feel like I'm missing an A. Oh no, the A is 0. Okay. So that's a good equation. That's a good equation. Something else is here that I haven't used yet, which is this. So this is looking suspicious. So this says the chance that you get 5, which is C, given that it's above 2. Okay, so C out of above 2, yeah, means that's 0.25 plus B plus C equals a half. Can I do anything with that? Yeah, let's multiply by 2 and bring this bit up. So 2c equals 0.25 plus b plus c. Okay, and I think I pretty much sort of have enough information, I don't know. I know I can find out b and c using these 2 equations, so I can get a with that as well. All right, so, you know, minus b plus a c is 0.25. I'm not going to do all the quadratic solving, sorry, the simultaneous solving, okay? If you put 1 and 2 and 3 together, I'll just double check them before I throw them in all in for you. So they've got 4a, where's my equation here? 5a, I'm just trying to find my equation, a plus c. Am I looking at the right question? No, I'm not looking at the right question. Yeah, I think these are my equations. So I've got an A value. I've got an A value now of, where is it? I can't see it. It must be 50 times 0.2. Right, a B value. Have I got a B value? No, again, I'm looking at the wrong question. Just give me a second. What is going on here? So this is question 7, right? Members of a photographer group, 14.8. Expected value is 3.2, yeah. 4b plus 5c is 2.15. Yeah. Okay, I just don't think they seem to be writing anything about A. Maybe it's because it's not important. So B is 0.1 and C is 0.35. Well, I can't help but write this down because I know that they will add up together. All right, so that's what A, B, and C is. Show that the variance is this value here. Okay, so I would now go and do my n squared values. So my n squared values are going to be 0, 1, 4, 9, 16, and 25. And remember, I know what these are now, okay? So I'm not going to have these values in here anymore. I'm going to have the real values, which are 0.05, 0.05, 0.1, and 0.35. And I'm going to just multiply all of them. So the expected value of n squared is going to be a case of doing 1 times 0.2 plus 4 times 0.05 plus 9 times 0.25, 16 lots of 0.1, 25 lots of 0.35. And all of that together is 13. Okay, so finally the calculation is for var is the expected value of x squared minus the expected value of x, or I should write n in this case, n all squared, which means it's going to be 13 take away 3.2 squared, which is 2.76. Okay, that was a lot of work, but I'm sure it was useful for the other bit. So the group decided to charge a 50p entry fee for the first photo entered. Is it possible to enter no photos? It is. Right, that complicates it a little bit then. Okay. And then 20p for each extra one, up to a maximum of £1 per person. Thus, a person who enters 3 photos pays 90, so 50, 70, 90. So that's what they're saying. And 4 and 5 is just 1, so they save a little bit of money. Assuming that the distribution is not changed, what would the sort of the money look like for that one there? Okay, so we go back to our table then, don't we? And it's a case of the probabilities are going to stay the same because we found them out. And maybe I'm going to add another column. So I'm going to add, like, say, price, for example. So price for the first photo was 50p, wasn't it? It's implied that if you don't enter any photos, that it's a 0 still. So this is a 70, this is a 90, and then this is 100 if I'm doing it in pence. Okay? Why am I doing this? Well, now what it lets me do is it just lets me kind of, multiply these again. So again, it's our table. Our table is kind of coming to the rescue. Yeah? So I'm going to just do all of those multiplications there. And you do, in fact, get 81p if you do all of that. Okay? The Poisson distribution you have not done yet. I'm not going to go through that because it doesn't make sense yet. Okay? But I hope that was helpful for that question there.